Hello learners, welcome to our lesson. My name's Chanda Chileshe and I'm your tutor. In today's chemistry lesson, our interest is to look at organic chemistry. And under organic chemistry, we are going to be looking at condensation polymerization. I'm sure you are familiar with this. It's not the first time that you are looking at this, some of us. All right. What we are going to be looking at is the formation of condensation polymers. We know that polymers are macromolecules, and these macromolecules are formed when small units known as monomers join together. And in the joining of these small units, there is elimination of water. So that is the most important thing to understand about condensation polymerization. There is elimination of water each time the monomer units combine or form a bond. All right, so we are going to be looking at synthetic polymers. We understand that we have polymers that are known as polymers and those that are synthetic, okay? Man-made polymers, that's the meaning of synthetic. So those synthetic polymers, we have addition polymers, we also have condensation polymers, but our interest today is to look at condensation polymers. Now, we are going to look at two types of synthetic condensation polymers. The first one will be nylon. And then the second one will be terylene. These are the ones that we are going to be looking at. We want to understand how they are formed and how water is eliminated in the formation, during the formation. So we'll start with formation of nylon. Formation of nylon. Now, when you're looking at this particular condensation polymer, first of all, the first thing that you need to understand is what monomer units are required for this polymer to be formed. There are two types of monomer units required. We have diamine, and then the second one we have dicarboxylic acid. Okay, so diamine and dicarboxylic acid are the ones that are required in order for this particular polymer to be formed. We also need to understand how to draw the structures of these monomer units. So we'll start with the first one, which is diamine, the structure of diamine. So this is how you write it. This is how you show diamine. Okay, that is your diamine. The second one is dicarboxylic acid, and dicarboxylic acid can be drawn like this. So this is your dicarboxylic acid. So when these monomer units combine, there is elimination of water. How does that process occur? So this is what is going to happen. The hydrogen from the diamine and the OH from the dicarboxylic acid will add, they will react to form water. So that is how water is eliminated. And then after this elimination of water has taken place, there will be a bond that will be formed between nitrogen and carbon. Okay, that bond is actually known as that is what we call the amide linkage. There will be a formation of that bond, the amide linkage, and that is why this polymer is referred to as a polyamide, because of the amide linkage. So how are you going to show the resulting structure when this molecule is formed? This is how you are going to draw it. You start with the diamine, okay, like that. You can draw it. a diamine, you draw it like that. So remember, there's a bond between dicarboxylic acid and the diamine. Now the bond is between nitrogen and oxygen. So this is how it will look like. So that is what you are going to see. So if you want to join some more molecules, you can join. The molecule is actually forming. It's polymerization that is taking place. So you can, that's why I've not included the OH there, because the molecule is still ongoing. If we want, we can add another diamine there so that we can form 2 units. So this is just 1 unit. So let us form 2 units. Okay, like that. Okay, we have formed 2 units. So that is how the molecule is going to look like. Yes, like that. I'm sure you've noticed that we have 2 diamine, here, this one and this one. We also have 2 dicarboxylic acid. So this is how the molecule is going to look like. And remember, I said that when the bond between nitrogen and carbon forms, that bond is known as the amide linkage. And this is the amide linkage. This is how it looks like. I'm going to show you the amide linkage, this one. So we also have another amide linkage there, that one. So those are the linkages that are there, that are forming. And each time this linkage is formed, there is elimination of water. That's why we call this as condensation polymerization, because of the removal of water that occurs whenever the amide linkage is forming. So this molecule, nylon, is known as a polyamide because of the amide linkage. And the polyamide, the bond itself that forms is made up of nitrogen, hydrogen, carbon, and oxygen. So this is the amide linkage. So that is how you show the formation of nylon. So in the next lesson, we are going to be looking at how terylene is formed. I think this is very easy, provided you are following all this understanding. Thank you so much for watching this lesson. Bye for now.